All right, guys, I've listed out a bunch of formulas for you up here. Just a heads up, if the formula is down here, I didn't write it out, but it will be given to you on the test. Remember, there are 3 different formulas for cosine of 2a. All right, so all these will be provided. These over here, you may or may not want to write down when you actually get your quiz on Friday. But you have to know them either way. So you may not need to write down that cosecant is a reciprocal of sine, but you need to know that as you're going through your quiz. The 3 you absolutely need to know are these 3 up here. Okay, and so again, I've talked to you guys about this in class, but I just memorized this first one. That's it. That's the only one I memorized. You're obviously allowed to memorize these, but I just find them by dividing the original Pythagorean identity by either sine squared or cosine squared. So for example, if I wanted this middle one, I'm going to divide all 3 terms by sine squared. Sine squared divided by itself is 1. Cosine squared divided by sine squared is cotangent squared. And 1 divided by sine squared is cosecant squared. Okay? And then I do the same thing with these 3, but with cosine squared. All right, so again, the very first thing I would do when I get my quiz is I would write out all these formulas, especially these 3 over here. Now, let's go through the questions from the quiz review. And obviously you can just scroll ahead if you need to. This is not for a grade here. So 2 tricks that we're going to use to solve these types of questions. We have our Pythagorean identities, and then we have writing things in terms of either sine, cosine, or tangent. Okay, so first question here, nothing is squared, so I'm not going to use, I'm not going to use any of these because these all have to be squared in order to use them here. Okay, with this one, all I can really do is rewrite tangent. So we can rewrite tangent of x as sine of x over cosine of x, and then just bring down the times cosine of x. Now we're both multiplying and dividing by cosine, so those are going to cancel. Sine of x is on top of the fraction, so our answer is just sine of x to the first question here. Now, second question, very similar. We've got cotangent times secant. We're going to write this as cosine of x over sine of x multiplied by 1 over cosine of x. All right, so I'm getting everything in terms of sine or cosine here. Now we have a cosine on top, a cosine on the bottom. Those cancel. But here, so the last problem, it was just sine of x and we were done. Here, sine of x is in the bottom, so it's 1 over sine of x, which we're going to write as cosecant of x. All right, let's take a look at 3 and 4. So 3 and 4 both involve Pythagorean identities, and the way that I can tell is that we have things that are squared and multiple terms. So I'm going to use a Pythagorean identity up here, but not down here, because I'd have to split this up into 2 terms, which I want to avoid. So again, if there's 2 terms and something is being squared, you're going to probably use a Pythagorean identity up here and up here. Okay, that's going to be our first step. Now, these are not the exact Pythagorean identities. 1 minus cosine squared is not in this identity, but we can rearrange sine squared plus cosine squared equals 1 by subtracting cosine squared over, and now 1 minus cosine squared is sine squared. All right, and so we can replace 1 minus cosine squared with sine squared, and now we have sine squared over sine squared. Now these do cancel, but think about it like this, we're dividing something by itself, so don't just cross everything out and then think that you're done, or write 0. Something divided by itself is equal to 1, and that's our answer to number 3. Number 4, we're going to use the identity that says that tangent squared plus 1 equals secant squared. We're just going to subtract the 1 over, so that secant squared minus 1 is equal to tangent squared. All right, we can therefore replace the top with tangent squared. Now, we can simplify more, but I don't want to use any more Pythagorean identities because it's going to give us more terms. We want fewer terms. I'm not going to expand these out here. What we're going to do instead is rewrite the top again, but in terms of sine and cosine. So rewrite tangent as sine squared of x over cosine squared of x. All that's going to be over sine squared of x. Now, some people do know we can cancel the sine squareds because it's in the numerator of the numerator and the numerator of the denominator. But if that is confusing, we're just going to do keep, change, flip. Okay, so let's keep, I'm just going to write this as s squared over c squared, sine squared over cosine squared. Change it to multiplication and flip this bottom fraction right here. Make it a 1 over sine squared. Our sine squareds cancel, leaving us with 1 divided by cosine squared. And dividing by cosine is the definition of secant. So this is secant squared of, I put theta instead of x, but secant squared of x. All right, so that's the answer to number 4. 5 and 6. Number 5, I see a Pythagorean identity right here. I can replace sine squared plus cosine squared with 1. But now we still have a squared term, and there's still 2 of them being added together, so we can use another Pythagorean identity here. And one of our Pythagorean identities said that 1 plus cotangent squared is equal to cosecant squared. So we can replace all of this with cosecant squared of x. And that's our answer. Number 6, the inside says cosecant squared minus 1. And so if we take that same identity and we subtract over the 1, cosecant squared minus 1 is now equal to cotangent squared of x. All right, so we're going to replace the inside here with a cotangent squared of x. Again, I don't want to use any more Pythagorean identities because it's going to add in extra terms here. We want to leave it at these 2 terms and then try to simplify more. We're going to do that by writing everything in terms of either sine or cosine. So secant squared is 1 over cosine squared, and cotangent squared is cosine squared over sine squared. We have 1 cosine squared on the top, 1 on the bottom. These cancel out, leaving us with 1 divided by sine squared, which is equal to cosecant squared. And that's our answer to number 6. Number 7. So a lot of people look at this one, they see the squareds, and they want to use Pythagorean identities. But again, we're going to go from having 1 term on top to 2 if you do that, or 1 term on bottom to 2. So that's not going to simplify it, it's going to make it more complicated. So instead, we're just going to write these in terms of sine and cosine. Okay, so we're going to have 1 over cosine squared divided by 1 over sine squared. Fraction inside of a fraction, we're going to keep the numerator, change the division to multiplication, and then flip this bottom fraction. Keep, change, flip. So keep 1 over cosine squared, change it to multiplication, flip that into sine squared over 1. Now nothing cancels here, but we can multiply these fractions, multiply the numerators together to get sine squared, and multiply the denominators together to get cosine squared. And now, sine divided by cosine is tangent, so sine squared over cosine squared is tangent squared. Make sure you remember that squared on that part right there. Number 8, nothing is squared. So I'm going to write everything in terms of sine or cosine. I'm going to rewrite secant, I'm going to do that right over here as 1 over, I'm just going to use c to represent cosine. Secant is 1 over cosine. Tangent is sine over cosine. These do not cancel. And then we have times cosine. All of this is over sine. So this cosine can cancel one of these 2. It doesn't matter which one. I'm going to cancel this with this one. Okay, so we can ignore the 1, sine over cosine over sine. All right, I'm going to put this over 1 and keep, change, flip. Keep, change to multiplication, flip the bottom fraction. All right, if we do that, we have sine over cosine times 1 over sine. The sines do cancel. Some people would have canceled in the previous step. It's fine as well. And now we have 1 divided by cosine, which gives us secant of x as our final answer right here. 1 divided by cosine equaling secant. All right, now for our sum and difference formulas. So I gave you guys one that is cosine, one that is sine. Again, these formulas will be provided. You have to know how to plug into them and to recognize when to use them. So our formula for cosine is cosine of A, cosine of B, change the minus to a plus, sine of A, sine of B. All right, and so we're going to use our unit circle to simplify the rest of this. The x coordinate at 3 pi over 4 is negative square root of 2 over 2. Multiplied by the x coordinate at 2 pi over 3 is negative 1/2. I'll come back to that part in just a minute. When we multiply these two, that gives us positive square root of 2 over 4. Okay, that's just the first two cosines right here. Simplifies into the square root of 2 over 4. Then we have a plus. Now I do the y coordinate, which is positive square root of 2 over 2. And the y coordinate here is positive square root of 3 over 2. When we multiply those, we're going to get plus the square root of 6 over 4. And now we can combine the numerators without actually adding them together. They're different numbers. I know it seems like we should be able to call that the square root of 8. Nope, square root of 8, but it doesn't work. Okay, it should be the square root of 2 plus the square root of 6 all over 4. That's our final answer to number 9 right here. Okay, square root of 2 plus square root of 6 all over 4. This one is also sine. Well, this one's sine instead of cosine, but it's sine of a minus b. So it's sine A cosine B minus cosine A sine B. All right, we're going to use our unit circle to simplify just these two right here. Okay, and so it's going to give us the sine of x times the x coordinate 11 pi over 6 is the square root of 3 over 2 minus cosine of x times the sine at 11 pi over 6 is going to be negative 1/2. Now this one doesn't really simplify nicely. You know what, I'm going to go ahead and just change some stuff about this right now in the middle of the video to show a little more how this would look on the quiz. I should have caught this beforehand. But let me change the angle to make this nicer. Let's say that this angle is pi right here. All right, so that's going to change this angle into pi and this angle into pi as well. And so it's going to give us a much nicer answer if the original problem was like this, which is again is how it will be on the quiz. Pi or pi over 2, 3 pi over 2, 0, something like that. So this is going to give me sine of x times the x coordinate at pi is negative 1. Then we have a minus the cosine of x, and the sine of pi is 0. So multiplying by 0 is going to wipe all of that out right there. 0 times anything is 0. Here I've got sine of x times negative 1, which is going to give us negative sine of x. All right, so this is a lot more like what the question will be on the actual quiz, not the original one. I apologize. I should have caught that before I posted it. All right, number 11. We've got cosine of 2x equals 4/5. X is in between these two angles. That means quadrant 2. If you're thinking unit circle, quadrant 2. We're looking for cosine of x. Now, before I actually get into this problem here, I know that the answer is going to be a negative number. And the reason I know it's going to be a negative number here is because in quadrant 2, cosine is always negative. Okay, think ASTC, right? In quadrant 2, only sine is positive. All right, we're in quadrant 2, therefore cosine is going to equal a negative number. We got to find that number here. All right, so we've got a double angle. Cosine of 2x equals 4/5. I am going to replace the cosine of 2x with one of these three, either cosine squared minus sine squared, 2 cosine squared minus 1, or 1 minus 2 sine squared. But because I'm looking for cosine, I'm going to choose the one that just has cosine. If I was looking for sine, I would use this one. And I would probably never use this top one for this type of question here. All right, so I'm going to replace cosine of 2x with 2 cosine squared x minus 1 and set it equal to 4 over 5. Okay, again, I'm just replacing cosine of 2x, what it's equal to here. Now I'm going to isolate cosine of x. I'm going to add 1 over. So if I add 1 to both sides, 4/5 plus 1, or 5/5, is going to give us 9/5. Now to move this 2 over, I'm going to divide everything by 2 or multiply by 1/2. Multiply by 1/2. I get cosine squared of x is equal to 9 over 10. 9 over 10. All right, all I have left to do now is get rid of that square. So I'm going to square root both sides. And that's going to give me cosine of x equals plus or minus the square root of 9 over 10. But we already said it's going to be a negative here, right? We're in quadrant 2, cosine is negative, so we're just going to keep the negative. We're going to get rid of that positive right here. All right, we can go just a little bit past this here. I'm going to break up the square root into the top and the bottom. So if I square root both of those, the square root of 9 is 3. The square root of 10 is the square root of 10. I forgot the negative that goes up front. So we just add in a negative right there. Negative 3 over the square root of 10, which if we rationalize, gives us negative 3 times the square root of 10 all over 10. Okay, this is our answer. So number 11, that's a tough question. All right, number 12. So we have these trig equations where we can use identities to solve, but it makes it kind of tough. And so what I want us to focus in on is instead of going through and using all the identities, factoring, solving using the unit circle, I'm just going to ask a point, right, that I want us to test and see if it is a solution. All right, so we've got sine of 2x plus 2 sine squared of x equals 0. So I went ahead and plugged in pi over 3 for both x's. So just there and there, plugged it in for both x's. Okay, and I just rewrote this, so sine of 2 times pi over 3 plus 2, and then in parentheses, I'm going to move the squared outside, okay, instead of being right there. All right, so 2 times sine of pi over 3 squared. Now, order of operations, we do what's inside parentheses first. And so 2 times pi over 3 is just 2 pi over 3. The 2 just goes on the top. 2 pi over 3. All right, so using the unit circle, I'm going to figure out the sine of 2 pi over 3 and the sine of 1 pi over 3. They're actually the same here. Both of them end up being the square root of 3 over 2. So I get square root of 3 over 2 plus 2 times, replace the inside with square root of 3 over 2 and square it equals 0. Again, order of operations, I'm going to do the exponent before I multiply. And so if I square both, I'm just going to do that all in the same step here. So if I square both of these, the square root's going to go away. Okay, just a 3, and then on the bottom we're going to get 2 squared, which is 4. Okay, so 3/4 right here. All right, now we're going to double this, okay, giving us 6/4 or 3/2, so square root of 3 over 2 plus 3 over 2 does not equal 0 because a positive number plus a positive number is a positive number. All right, if you want to simplify a little more, we'd write it like this. You can't actually do anything with this, okay, but it does not equal, so no, it's not a solution to this one. Okay, now I know a lot of people want to know the real way to do these, and so I did go ahead and work that out up here. So what I did is I used a double angle identity to replace sine of 2x with 2 sine x cosine of x. Then both terms have a sine of x, and so I would factor, this is wrong. Let me fix an issue real quick. That's not a 1. Okay, so this whole part's going to be messed up. All right, now I can factor this correctly. Factor out a 2 sine of x. The first term becomes cosine. The second term would become sine of x. Okay, I forgot the sine of x there. Set both of these unequal to 0. So I went ahead and set 2 sine of x equal to 0 divided by 2. These are my solutions on the interval from 0 to 2 pi when sine of x is equal to 0. Let's do this one now though. I would set that equal to 0. So cosine of x plus sine of x is equal to 0. Subtract over sine of x. And now there's 2 ways you could do this. You could either go around the unit circle and look for when are the x coordinates equal to the opposite of the y coordinates, or we could divide over sine to make this a cotangent. All right, divide both sides by sine, cosine over sine being cotangent, sine divided by sine being 1, and now figure out when the cotangent is equal to -1, which would have 2 solutions of 3 pi over 4 and 7 pi over 4. Okay, so these are the solutions. What we said earlier was that pi over 3 was not a solution, which just didn't show up in this one. All right, so I don't know how many people actually made it this far in the video, but that would be how you would do that the real way, which you're welcome to do on the quiz, although it's, I think, easier to plug in and see if you get the number over here. All right, good luck on your quiz on Friday or whenever you take it.